Welcome to the Infill Podcast, where we interview the most interesting members of the 3D printing and maker communities live and with audience participation. And now, here is your host, Jonathan Levy.
Greetings, welcome everyone, and welcome to the only reason I ever tidy this place up. I'm really excited to have you guys here because we have an extra special guest. It is not every day we get to interview someone who is running a business in 3D printing and at a scale that I think none of our guests so far have ever done. You probably know him as Slant 3D, but he has a real name. It is Gabe Bentz, and he's the founder and CEO of Slant 3D, where they believe that the future is one in which the shelves create the products in warehouses. Gabe, welcome. Thanks for coming on.
Thanks for having me on. This is going to be fun.
Yeah. So tell us a little bit about your background. I think anyone who's seen your content, which, by the way, congratulations. I saw your channel is growing really rapidly, which is always awesome.
Oh, thank you.
Anyone who's seen your content knows that your background is in 3D print farming, but I don't know if you shared how you got into all of this. Like, how does
against
one
my will
end up running such a large 3D print farm?
I did not want to get involved with 3D printing at all when the whole thing got started.
Really?
No, I didn't get involved with printing until like 2016 or 17 or so. Because when I was coming up, I went to school and 3D printing was just starting to kind of show up inside of school. And what everybody would do is they'd try to 3D print everything. Because I studied mechanical engineering, and every engineer always wants to use the latest, greatest thing to make a thing. But the issue with it is that you end up making like a board with a hole in it and saying you should 3D print it, which is dumb. You just go to the wood shop and drill a hole in a board and go on with life. So I was just kind of negatively biased towards it for a long time. But then it was at Slant Concepts, which was a product design company that was the parent company for Slant 3D, where we created a series of products that had to be printed. And we thought, well, we'll make 100 of them and we'll move on with our life. But they ended up being successful. So, darn it. So we had to build a small print farm to produce those things. And then it grew from there, and we realized that there was no reason that printing shouldn't be able to match injection molding or any other process. Every process has electricity, the raw material, and then some sort of ancillary parts of the process.
Right.
With molding, of course, you have the mold and the shipping and stuff around that. Printing has only electricity and the plastic, so it should be the most efficient manufacturing process. So on that premise, we started working backwards and saying, okay, why is it so expensive and slow and terrible right now in 2017, 2018? And it was mainly machinery and the automation inside of it. So we ended up starting to design highly automated printers that were able to operate at scale reliably, which means we had to fully disconnect ourselves from like the consumer 3D printing kind of world where the focus is very different and doesn't really work in production very well. Yeah.
So I already have a lot of questions from what you said. I'm going to try and remember all of them as I ask. What was that product? I'm always thinking about, someone asked me the other day, they're like, can you really 3D print like any plastic part I buy in the store? I was like, I can 3D print stuff that you can't, because it can't be made in any other way. So I'm curious what those products were. One, that were successful right out of the gate, which is super awesome to hear and not what you typically hear in entrepreneurial stories. And two, that could only be manufactured with 3D printing.
They could only be manufactured with printing mainly because of our laziness. When you're lazy, you don't design for the mold and you just block together something. So they were chunky and wrong and had been prototyped on a printer. So we used the printer's capabilities to kind of fall into it to where it wasn't good for molding. Our products themselves were called Little Bots, which were a series of STEM robotics kits. So it was a little Arduino robot arm that you could kind of program and run with an Android app. So the kids could stick them together and build these little robots. And we were printing the parts. So you could either buy the raw parts for it and print them yourself or print the whole kit. And the whole kit was the one that ended up going into like actual retail eventually, like brick and mortar on the shelf in a box kind of stuff. But those kits, the reason printing enabled them so much is because number one, at the time, If you're making a robot arm, you want as much little weight at the end of it as you possibly can. So printing is really great because you can make something structurally sound but very lightweight by using the infill. Longer term, as we started evolving the designs, we were able to input compliant mechanisms and that kind of stuff. So like the fingers didn't have screws anymore. So they got simpler and simpler to create and assemble, while still also having this really monolithic and good look. Because if we had molded them, then you end up with this kind of skeletal sort of design language as you try to cut out voids and make thin walls and ribs and that kind of stuff. I don't like injection molding aesthetics if you have to expose the parts. 3D printing was able to make this very kind of cushy kid toy looking style that looked really good, and gave us the structural capabilities, the integrated components. And then with Little Bots, I come from a robotics background, but a good software bent to it too. I like to be able to iterate really quickly and change the product dynamically. So it was amazing that we were able to evolve the product about every couple hundred or couple thousand units based on the feedback. So it was continuously improving and evolving. The Little
Which
Bot
reminds
YouTube
me of
channel,
the second question you prompted in your answer, which is, you said, you had to design printers that were built for scale and for running continually, and that took you away from consumer. On the other hand, we have, Prusa, who famously uses, I think, modified versions to a large extent, but modified more for the heat of the environment, right? And the bigger spools and stuff. So what's your take on that? Do you think Prusa's they're using their consumer printers also because it's a test platform for them to test their actual consumer printers? And so I guess the answer is, if they weren't selling the printers, they would have gone a different route in designing them for a farm.
I would say that the farm is half and half marketing, half and half the actual engineering of it, which is kind of unfair because I don't know what's going on inside of there. But I would definitely have the farm printing my printers if I possibly could, if I was in that business.
Yeah, of course.
The thing with it, though, is that it is a fundamental for them with those machines. They are fundamentally limited by scale, because those machines are just slow, and bed slinger machines are horrible for mass production. When we designed ours, we designed them for auto ejection. So there's never dead time on them. When the machine is done, it removes the part, it moves on to the next one. Whereas Prusa has a lot of attendants pulling off beds and popping parts and all the rest of it. They also have to fill out the build plate with a ton of parts per build, which is a dangerous way of doing it because you increase your scrap rates when you do batches on a build plate. Because if one part goes, it takes all the rest of them with it generally. So we don't run like that at all. But again, because Prusa is trying to prove their machines, and they're reliable enough to work, and that's fine. But they also have a machine factory to support them. So if a machine goes down in a substantial way, they just swap it out for a brand new one that's working fine. So they're not in a maintenance cycle. They're not a service bureau. The other thing is that print farms that make narrow products or like singular products have it a lot easier because you know what the part is going to be, and you effectively tune the machines towards that part or series of parts, and certainly particular material. Prusa only has to make orange PET G, so they never have to swap back over to white PLA or something like that. So for us as a print on demand service provider, effectively, it gets a lot hairier a lot more quickly than if you're just producing the same thing over and over again.
That makes a lot of sense. And as we said, there's a lot of marketing in that. And it's great marketing. And I think there's a lot of look, when they launched the Mark IV, they're like, we've done, I don't remember what the number was, but it was like 100,000 hours of testing or something and maybe it was 1 million. And it's like, okay, that's what the Prusa farm is actually about. It's actually about testing their products and beating them to death so that the consumer gets a better product. By the way, Ferrari's the other way around, actually. Ferrari only makes road cars to finance the Formula One. But in Prusa's case, they make consumer print, or they use them in the, you get what I'm saying? I've confused myself. I think so.
Yeah.
But it's one of these what's the interrelationship between the consumer printing and the industrial? And in Prusa's case, it's Yeah, we could probably design a better printer. I mean, they have, right? They have the Prusa AFS automated farming system, but they
Yes.
don't use it to make Mark IVs,
Yes.
which is
Yes.
interesting.
Exactly
So I
right.
think I answered
It
my own
is kind of
question. So for folks who aren't familiar with Slant, rather than having you pontificate on other people's print farms, tell us about your print farm, because you guys have like hundreds of machines, all different technologies. Give us the spiel.
Not all different technologies. We are FDM exclusive.
Ah, okay.
Of almost every bureau is that they try to diversify really quickly. And I think that's a way to kill yourself really fast. So like, oh, we got to get
Right.
resin, we got to get large format and that kind of stuff. I really pontificate against that model because you never get good at anything. And right now, FDM is not fully understood even by us who do it only.
Right.
But yeah, we do FDM exclusive. We only have one version. Well, we only have one style of machine. 14 versions of it inside of the farm, but they're all backwards compatible.
Got it.
We still manufacture our own machines. But yeah, with a print farm is fundamentally a very complex system because you have thousands of individual machines inside of it. The Boise Mega Farm here that we're in is spec'd out for 3,000 machines.
Holy
So it's a big
crap.
monster. Yes.
How many machines are in there now?
We're still a little bit short of that, but we're getting awfully close. And we may pass that to the whole building can hold 5,000. We just don't think we're going to need that many that soon, but we have enough power and space for 5,000 if we really want to.
Whoa. Okay, but I'm also remembering you specifically said you guys don't like to plate parts. Like you'll use a machine and print one part at a time because they're auto ejecting.
Correct.
Which, by the way, so the next question I want to ask is, I imagine that there was a huge cost savings element in addition to customizing the machines for your needs. Do you have any idea, and do you mind sharing what it costs you to make a machine that you're like, yeah, we can scale up to 3,000 machines? I mean, what does it cost to make a machine that way?
The machine.
Okay.
I can't share that. There's a bit of a cost savings to it, but quite frankly, since we're still a relatively small organization compared to like the consumer printer companies that are producing thousands of these, so they're just more efficient than us. So even though yes, we bring it internal and we have that vertical integration that gives us, we don't have to pay the wholesale price margin and that kind of thing.
Right.
It sort of ends up kind of balancing out most of the time because we're a little bit more inefficient than they are in the production of the machine.
Yeah, and you're probably not buying aluminum extrusions by the metric ton. Or maybe you are at 3,000 machines. Maybe you are. So let me ask you this then. When you, let's say tomorrow you go, okay, we're going to scale up. Let's put 100 more machines in the farm. From the day that you make the investment, do you know how long it takes you to pay off a machine? Or how long does it pay for itself?
The margins of production vary throughout the year.
Okay.
So they're like throughout Christmas season is like the peak season. That's when you're just getting stuff out the door. And very often it's very high margin because it's like, okay, cool. These are the good parts. Everybody's optimizing around their highest sellers and that kind of thing.
Right.
And then also we have like an internal e-commerce brand, which also contributes to that. Throughout the year, especially in mass production, you're competing with molding. Now, molding has a gross margin of 3% or net margin of 3% at the end of the year. It's a terrible business.
Right.
But if we're competing with them, we either have to be way more efficient or have some other kind of value to give us a larger margin, but it's still not, 200% because I made it for $1 and sold it for 20 or something like that. We can't do that when we're operating at these scales because companies are like, no, you're going to make the part for 10 cents a pop or whatever else it was. It's like, all right. So in the off-peak season, margins decrease quite a bit to where the payback time is longer, depending on the time.
People are less willing to pay a premium for expediency.
A premium for scale. The bigger you get, the more efficient you're supposed to be. So you should not be grabbing giant margins from people if you're making 100,000 parts for them. Yeah.
Right. And you guys, as I understand it, are much more in scale, right? If I need to get 10 of something printed to send to my regional managers, that's not Slant.
Well, there's two sides to it. There's the kind of B2B side, which is, like 1,000 parts plus. And then there's our print on demand side, which is like Etsy, our API, or our print on demand app where you can.
Dude, I need to get on that. I keep forgetting. I'm putting this on my to-do list because I closed down my Etsy store because Israel Post is
Oh,
the
really?
worst business to deal with on the planet. Every time I
Do
need
you
to
ever
ship something, they close a branch. Like that's how bad it is.
Yeah,
Um,
that's rough. Well, to be fair,
personal.
you guys kind of have an excuse right now. So
We got a lot going on. Yeah, that's fair. But it's been that way for the last few years.
okay.
Check out Slant 3D, not sponsored, but check out Slant 3D for Etsy. It's on my to-do list.
Yeah.
And that I
We're trying to
imagine,
keep that.
yeah.
No,
Huh.
the Etsy app, the Etsy integration has been a fantastic project because it's grown really quickly, even though we've kept it like really narrow. Because we're like, you can only print in black, white, and gray on the Etsy integration right now. We haven't released like colors or anything yet, but
Yeah.
we're just putting out the fires that exist as it's scaling up there. But we think that's where a lot of it will grow, because there are all these folks who don't want to build print farms, because a print farm, quite frankly, is miserable once you pass like 10 machines, because your life becomes the print farm and you
Right.
love it for a while until you've changed, I don't know, the 200th nozzle and the 10th blob and all the rest of those kind of things that just come from having to build a factory.
Right.
So we think we'll be able to enable a lot more people to try to start businesses through those kind of things.
Definitely. Well, it's, we were talking about Boise, Idaho. For my book, I never shipped a single copy myself. I had it always printed on demand in Boise, Idaho, by the way, or I had them
Yeah.
warehoused in
Oh,
Boise. Yeah, Ship Zoom.
did you? Oh, ship Zoom. Okay. I
I
was
like
like, why didn't you go through like the Amazon thing or something like that?
so I did for
Okay.
Amazon actual sales on Amazon, but for my own book funnel, to be able to give a book away for free, which I was doing. It's like just pay shipping, get the book, and then there's a back end on the book
Right.
of, hey, check out the courses and coaching and stuff like that. You got
Sure.
to be able to get those books for $1.50. So if anyone needs books, by the way, I just recalled them back from the warehouse because I'm not doing that business anymore. But we were
Gotcha.
buying like 5,000 books at a time to get those prices.
Yeah, for sure.
So okay, every answer gives more questions, which is great. Josh Edlin wants to know some specs on these machines. Like, what do these machines look like? Volume, hot end, speeds, Core XY. Look at that thing.
They are technically Cartesian. They look like Core XY. This
Right.
comes up a lot, but since each individual axis has an individual motor and an individual belt moving in just that axis, it's a Cartesian machine technically.
Okay.
Very skeletal. The main thing that we went through was making them not user friendly, because we did not want displays. We wanted them really headless. We wanted them very basic and even kind of
Right.
ugly, because when you're building a production machine, you want it maintainable, which means I
Yeah.
do not want anything behind a panel. I do
Right.
not want a bunch of cool GUI interface touchscreen stuff. I want something that will work. So we use like a twist knob if we have a display on it.
Right.
Though, quite frankly, with our new production software, Kraken, coming out, we may be able to kill the display on the machine, which means we don't have to buy displays for the machines anymore. And it's going to be really sick. You're going to basically just scan a QR code with the app, and control of the printer will pop up on the app screen. It's going to be sick when we get that one deployed.
Why
So
not
we won't
control
ever have
them
to
all
have
from just one? I guess you have too many to control them all from like one computer at the end of the aisle.
Oh, we have that too. But if
Okay.
somebody's doing maintenance or wants to like stop a print while they're walking aisles or doing collection, it's right there, and then you like readjust it and move it down and that kind of stuff if you're troubleshooting.
Yeah. And I mean, I imagine speed isn't a big concern on these machines.
Oh, speed is a concern. So we do have the high speed generation in the farm right now, but yeah, with a print farm, the main thing you're fighting with is parallelism of just, okay, if we want to go faster, add 50 more machines and now we're producing faster. Because it's not a per part speed that matters, it's a per project speed that matters. So if you finish the project in a week with 10 machines, you can finish it in 3 days with 20 machines. You just doubled your speed without having to have the high speed machine.
Right.
That was the premise very early on when we were starting, of like, we can just build a ton of machines and we hit the scale that matches molding. But high speed, of course, is important because it does give you more. High speed right now, though, is a little bit misleading because it's centralized to very particular materials,
Right.
in very particular contexts and very particular designs. Because if physics still hurts, melting something and cooling it back down to solid has to happen in a certain period of time. And it's really tough to go super high speed and have a reliable part come out that's not an ice cream cone.
Right.
So the high speed has not been hugely overwhelming to us. It ends up being about like maybe a 20 to 30% increase in yield generally.
So here's a tough question, because I'm seeing more and more of the people that I know running farms switch. It used to all be Prusa. If they're not, engineers like you and can't design their own printers, it used to all be Prusa. And I'm seeing more and more people. I was talking to a buddy yesterday. He's like, I'm going to pick up 3 or 5 or 10 more P1Ps or P1Ss. I don't remember during the sale. If you were starting it out today, do you think you'd still go the route of designing your own printers and building your own printers?
Definitely.
Yeah.
The reason for building our own printers was not necessarily cost. It was product roadmap. A consumer machine is intended to become as easy as possible to use for a guy who's a hobbyist or somebody in their office or garage or whatever it happens to be. It's a tool. A tool is not this, or an appliance, if they're trying to shoot for appliance, which bamboo kind of is not useful in a factory at all. The other issue is that if we bought 3,000 Bamboo Labs machines tomorrow, in 6 to 18 months, our entire factory would need to be rebuilt for the next generation of machine. It's kind of like what they did with the A1 with their distributors, where the P1P and P1S came out and they stored up a bunch of those, and then the A1 came out, and that became the low-cost machine that was still high speed and printed well. So everybody got left with this inventory. We have to have a machine that is able to operate for 5 or even up to 10 years in order to get true scale and true manufacturing, to be able to build a factory around it and make the investment of thousands, hundreds of thousands of dollars to build out these giant systems around them, both on software and staff and production workflow, to where we can't have our machines go to zero value every 18 months like you would with a consumer machine.
Sure.
The value of us building them ourselves is that depreciation doesn't go to zero anymore. Our machines depreciate and wear out, but they wear out back down to like the core aluminum extrusion again.
Sure.
And then once that machine is ruined, we tear out the shit chip, put on some new bearings, put on a new chip, and now it's upgraded. Or we tear out all the good pieces that are good and put them back into the assembly line.
That makes
so we depreciate
sense.
back down to the cost of raw materials.
That makes
we
perfect
have
sense.
A lot of reliability. Yeah.
And you wouldn't be able to do that with, like you said, like if you're building on a P1S platform, that's gone. Yep. I mean, I guess one could argue if you had done Vorons, but who the hell wants to build 3,000 Vorons? I've built 3 Vorons, and that's more than enough for me.
Yes. And they're not designed for assembly. We have to design these machines for manufacturability. And a Voron is, a project that doesn't work in an assembly line because it's got too many screws in it. I'm on a war against screws all the time. I'm so proud of our machine over here because I think it has 17 screws total in the whole machine.
Amazing.
Yeah.
And like, put in a perspective for me on the spectrum of consumer printers, because people are asking in the chat, they want to know a lot about these printers. Like, how fast or slow are they compared to like a Mark III or something like that?
They're faster than Mark III. The speed of the machines right now, physically, they're able to match a Bamboo Lab speed.
No kidding.
On our latest generation. Oh yeah.
So Input Shaper obviously running on them. I imagine Marlin though.
It is still Marlin, but we actually partnered with another startup that effectively created a control algorithm really similar to Bamboo that we effectively licensed their software from for the next generation of software.
No kidding.
And then we upgrade with our version 15 machine. We upgraded hardware a little bit because, we did a number of things with the extruder and that kind of stuff that made it really cool. But it lightweighted it so that it's easier to run at those speeds. But again, with the high speed, the thing that we really care about is not necessarily the speed of the print, but the overall reliability of the print farm over time. Because most print farms, even with modern machines, have a failure rate of somewhere between 5 and 10%, just because bed didn't stick or got dusty or whatever it happens to be, or the part's weird. We have to shoot aspirationally for below 3% in order to be viable at the scales that we're operating at. Otherwise, you just have too much waste. And while we're able to deal with waste because we like can recycle and re-extrude material and that kind of stuff, so it's like, oh, it's circular, you still don't want to deal with that because that's lost print hours. And regardless of how fast these machines ever get, you're still trying to get more work out of them all the time. So that's a bottomless spiral that we'll always chase. But there is no bottom to it. It's mainly just building more machines. The fundamental thing that we can do to actually increase scale, it will always be to build more machines.
It's really crazy to me. The whole operation is very first principles, because I interact with a lot of people running print farms. There are people in the chat running print farms, but you guys have really done it from first principles. Like, okay, let's not just buy printers. Let's build the best printers for us. But I think there's something to be said about the fact that you are a 3D printing business, whereas a lot of people running print farms, like out of darts, right? They're not a 3D printing business. They're a business that uses 3D printing. But you guys are really, in a sense, I mean, you are a business that specializes in 3D printing. You kind of should have the expertise to build your own 3D printers, and that's your core competency. Whereas out of darts, it's like, dude, 3D printing is just a component of our business. Or Trav from Shop Nation,
it enables their business.
Exactly. So I guess it makes sense that you guys, drink your own Kool-Aid. I don't know if that's the saying.
Yes. Or eat our own dog food. Any of those things. There's 12
there you go. Eat your own dog food. Yeah. Get high on your own supply, if you will.
Yeah, all of it. Yeah.
Let's talk. Speaking of supply, let's talk about filament, tangled filament. Was it about a year ago you decided, F this noise, we're gonna make our own filament?
Yeah, it was about a year ago. We did a video whining about filament on the channel. It was like, these are the 5 problems with filament. And it was literally kind of a letter to our manufacturers where we could just send it to them. I'm like, this is the problems that we have every time whenever we order batches from people. But the response to the video was such that we thought, Slant 3D has way too many things going on. So we always try to say no to projects as much as possible. And we've said no to making filament for a long time because we make it for ourselves internally. But whenever you turn it into a product, you give yourself a whole new round of problems, because it's never like, oh, well, we'll just scrape it off the top and shove it out the door. You're like, oh, it'll be easy. But no, you got to package it and sticker it and have the customer support and all these things. So it turns into a whole thing. But we were dumb and decided to go ahead and do it anyway. And
you know what they say, the line between bravery and ignorance is a fine line.
Yes. It's very much that thing. But it was also, we were in a unique position since we were producing our own filament, but the actual business that pays the bills is 3D printing.
Right.
We're effectively able to take a hit on filament or like break even on filament where no one else can. A filament manufacturer can't break even on filament because they go out of business. We can because we have the ancillary business, which means that we could both put price pressure on the commodities, because PLA is a commodity. It should be affordable, and it shouldn't be $30 or $40 a spool ever. I don't care what you're making or how good it is or what color you got. So our premise was black, white, and gray filament should be dirt cheap or at cost, because right now it's a bottleneck for us. Raw materials is a huge bottleneck because everybody's still making filament for consumers, and consumers, again, have a different set of priorities. A guy buys a single spool and he doesn't know that spool of black is slightly different than this spool of black over here.
Right.
We notice when 10,000 parts are lined up alongside each other and like, oh, they purged the extruder from blue over there and it's got a blue tint. That really ticks us off. But a normal guy wouldn't notice.
Yeah, because he's not dealing with the quantities.
Really yeah.
That makes so we thought, okay, sense.
We'll just take filament through the floor. We'll make our money over here, and just it'll be a good incentive for us to continue and improve our processes. And it's been kind of a nifty sort of, obviously we're in the States. I enjoy being able to match Chinese manufacturing of filament on pricing right now. That's really satisfying, because we should be able to. And kind of from just a standpoint of national pride, filament is not that hard to make. It's not, oh, there's low cost labor over there or anything else. Filament is highly automated already.
Right.
So it should not be expensive. We need lower cost raw materials so other print farms can scale up, because the existing supply chain just doesn't work and not everybody's going to be able to put an extruder like us. So it enables that. And at the same time, the community gets good, reasonable low cost filament. Pretty good.
The idea essentially is, you guys will benefit, even if you sell at cost, you guys will benefit by getting a lower cost of your own usage.
It increases our scale. Yeah. So we
Right.
can buy more pallets from the main distributor, which gives us a better pricing over there, and the cycle continues. So
Okay,
just
cool.
a way to get bigger gives us more efficiencies.
So I want to ask you about filament composition and stuff like that. But first, I do need to thank our sponsor, which, as always, is PCBWay. Now, I don't know. I should ask this. Do you guys do any metal 3D printing, injection molding, any laser sintering, any CNC? None of that. I don't do any of that either. The beauty of it is I don't have to because of, there's the segue. Today's sponsor, which is PCBWay. You guys, they do everything and they do it well. They can do 3D printing for you, but really I actually use them for everything beyond that, which is the CNC machining, the getting metal 3D printed. PCBs I've never used because I don't know how to design my own PCBs, but I have used their CNC services. I've used their machining, I recently had something 3D printed out of metal, which is awesome. And I highly recommend them. There's a link in the description. Check this out. 3D printed metal tool steel by PCBWay. Wait, there it is. Wait.
Oh, there
amazing. Amazing. I got my hex on one side, this on the other. Can't beat that.
Oh, nice.
So check them out. You get $5 off your first order, and they're fantastic. They don't make filament, though. So let's talk about filament, which is, I think, a super interesting thing because, as you said, PLA itself is a commodity. Now we're seeing so many composites. By the way, I'm going to put on some orange sunglasses because otherwise I'm not going to sleep tonight. Like, the lights keep me on forever. A little bit bad, but it's better than being awake till 2 a.m. I used to do this when I ran a health podcast and everyone just got it. Here, I think people are going to be like, what the hell?
What are you doing with your safety glasses on?
Yeah. So today, though, we're seeing a lot of innovation in filament, and we've got all the PLA Pros, and we've got PLAs that are holding up to. I mean, I have actually a espresso cup out of PLA, which I've sanded down properly and made food safe and has no micro cracks. I've done all of everything, but I can put espresso in there, which is 95 degrees Celsius, and it doesn't melt, and it's PLA. Blows my mind. So what's your take on that? I noticed you specifically said like black, gray, and white, the basic filament. But do you think that that is a way in which manufacturers can justify earning higher margins? And, you know, it's one of these not race to the bottom situations. Or is it all marketing?
A lot of it is marketing.
Yeah.
I mean, it's kind of like the Nike situation. Filament is a commodity shoe right there. So figure out how to sell it and get people on board with it. That's also been a fun case study in Tangled. But as far as what manufacturers can do, I think number one, I think manufacturers have a lot of value in being able to create a lot of different colors because batching those different colors is hard, and creating sparkle and chartreuse and whatever it was. For the consumer market is great because people do want very specific colors in those things, but you're chasing the long tail. It's not the bulk of it. I think there's a lot of margin to be had in good quality mass produced filaments because the scale of printing in our scale, the industrial scale, is going to break loose as soon as more people get used to the idea. And that transition is happening right now very quickly in a way that I don't think the industry even understands because we all talk to each other. We don't talk to people who are buying parts or making parts.
Sure.
But yes, specialty filaments, specialty colors, those solving particular problems is really useful. So like ESD safe filament, and everybody does carbon filled, but that's just because carbon fiber sounds cooler than glass filled or whatever else it was. Glass filled does the exact same thing because carbon fiber is mainly just to eliminate the layer lines anymore.
Right.
And you can do that with glass beads, but that doesn't sound cool. But if the filament manufacturers wanted to make something sound cool, they'd stop using names like PETG and PLA and these other 3-letter words. They just say like Uber filament or something like that. It prints at 220 and it holds up to 400 degrees or something. That would be a good choice. So there's a real easy marketing tip in that whole thing. Sure. But Yeah, specialty filaments that solve really particular problems. I think is good. So like companies like 3DX Tech or Sensium over here in the States are making these engineering filaments that are like, oh, this is fireproof, this is
Yeah.
highly UV resistant, so on and so forth. I think that's a good way to do it.
Totally. Totally. Well, I went to business school and I didn't learn very much at all, besides the fact that my liver was about ready to give out. But one thing I did learn is, when you're in a red ocean market, right? This whole blue ocean
Yeah.
strategy thing, that was actually written at my business school. It's their claim to fame.
Really?
Yeah, yeah.
Nice.
And the whole
That's a
thing
great
is like
book.
when you're in a red ocean of, commodity, find a way to get into a different ocean. And so you have companies like Protopasta doing like
Yeah.
gorgeous. I actually have a video coming out. Should I say? I'll say. I'm doing another video in my series of like the most beautiful filaments to level up your projects, right? So, okay, if you're going to be printing something that you don't really want people to know is 3D printed, like what are the latest gen filaments? Because we've moved on so far beyond the matte, the silk, the dual extrusion, the like we're way past that, guys. All right, get on board.
Yeah.
There's iridescent and there's so as you said, right? Like the blacks, the grays, and the whites, those are commodities. If you're printing in scale, like that should be dirt cheap by now. That should be
Yes.
your Honda Civics, right? Like
Yeah.
so little margin on a Honda Civic, a lot of margin on
Yeah.
a Rolls Royce.
Yep. Exactly right. It's all about the scale.
Huh. So people are asking some good questions, and ladies and gents, feel free to ask questions. I save them and then I ask them later. I wanted to know, how much filament do you guys go through in a given month?
Oh, again, varies depending on the month and that kind of stuff.
Mm-hmm.
Oh, you know, I the actual consumption, it really does vary because of the different rates of speed and that kind of stuff. So like if we're printing at a 0.3 resolution and a bunch of easy parts or whatever else it was, you go through a ton. But if you go have somebody who takes a project that's high resolution, then it's taking up print time and you do a
Right.
lot less. So it varies so much. But yeah, we order it certainly. We don't order fewer than 2 or 3 pallets from a supplier at any given time.
Wow. And a pallet
At any
is a metric ton?
About.
Yeah.
Yeah. It's a little bit less, I think, because yeah, the spools don't pack tight enough. But we generally get it on big old master spools, which are 25 kg, and
Wow.
yeah, there's generally 16 of those on a pallet.
Now, why filament instead of pellets? I would think at your scale,
Oh,
it makes sense at some point just to print from pellets.
oh, this is totally fair. A pellet extruder is an overcomplicated machine that will always be an overcomplicated machine that adds more parts to the printer and
Right.
adds less control because it's experimental. So we don't even have a roadmap for pellet extrusion because the cost to turn pellets into filament is trivial. It's a little bit of electricity and you run it
Right.
down a hot water tank.
Right.
Extrusion should not be an expensive, high value add process to turn pellets
Right.
into something else. So for us, we don't consider the conversion of pellets into controllable engineering controlled filament to be a big step to where pellets are a huge advantage over the complication that they add to the machine. Because I don't care if somebody gets, oh, it's a nice new extruder that works really reliably on desktop machines. I'm like, I don't
Sure.
want that second mechanism multiplied 3,000 times through our facility because it's
Makes
going to
sense.
break. Each time you add a part, it's going to break. Whereas having a single pulley push a line through a hot nozzle is as simple of a mechanism as you can possibly get.
Well, and you're
So yeah, we're not.
also, it's almost like pre-digesting the plastic, right? Like
Yeah,
you're taking
yeah,
pellets as standard as they are, they're not exact. You have sometimes a pellet that's a
yes,
little bigger, a little smaller, whereas
yes.
1.75 millimeter that's been already measured and extruded through the system,
Mhm.
it's kind of like pre-chewed, pre
Super
half
reliable.
digested.
Yes,
That's
absolutely.
that's validating and vindicating because I'm doing my filament recycling project, which is a freaking disaster. And if you want a good laugh, watch me try non-engineer here, not a quant poet, trying to build filament extrusion and even the shredding and it's a mess. My whole
Yeah,
thing's a mess. Anyway,
yeah,
um,
To be fair to filament extruding, we say it's a really simple process, but the devil is in the
Well, the
details and all
extrusion
that
is
stuff.
actually the easy part. The hard part is
Yeah,
grinding and
prepping
getting it
everything.
ground up, which I'm sure
Yes.
you've figured out. Although you guys are big enough that you probably just bought a good commercial shredder. I'd hope. I'd
Yeah,
imagine.
we
You
have
know.
some advantage in that kind of stuff.
Yeah,
Yeah,
I'm trying
but
to
even
piece it
then,
together with a friend of mine recently told me a lovely saying that they have in Russian. The way that I build things, he's like, "You build things out of shit and sticks." I'm like, "Yeah, that's pretty much
but by
my
golly,
style."
a lot of that Russian stuff worked pretty well for a long
Right?
time.
They got to space with shit and sticks.
Yeah,
So, but yeah, no, it's first off, that is the harder part, is getting everything shredded down properly, not overheating
yeah,
the plastic and melting it when you're shredding it.
yes,
And then extruding it is, as you said, pretty trivial. It's a
yeah,
glorified, simplified 3D printer, right?
yeah.
Because you don't even need an
It's a
X
big
and Y
bubble.
axis. I mean, you do, but it's just turning the spool.
Yep.
Wow, we're getting some great questions. Do you guys have somewhat? Few people have asked. Do you have plans to ship tangled filament to Israel?
We're trying to get to international, but the only way to
Cool.
do international right with filament is to do distribution, where you ship over a pallet
Yeah.
or a container load of it and then distribute it around.
Mm-hmm.
That's a ways out.
Yeah.
And shipping it from the States is just a monster because the post office is going to flag it or the customs is going to go
Sure.
crazy or something like that. So it just turns into a nightmare.
Well, when you're ready, I
And we
can
got room
connect
to
you
run.
to just about every retailer here.
Oh,
Uh,
fantastic.
Zrizzy wants to know why you guys picked FDM and not SLA or any of these kind of crazy industrial HP wild, MJF printers.
Our main North Star is a warehouse where the shelves make the product.
Mm-hmm.
That means that a normal human can wander down an aisle, pull a part off a shelf, and throw it into a box.
Mm-hmm.
That is not possible with resin or powder or anything else.
Right.
Also, from a manufacturing standpoint, powder and resin both require post processing forever. People say, oh, if FDM needs supports. No, if a part is appropriately designed, it does not need supports. So you can have a finished part come off an FDM machine if you do it right. You cannot have a finished part come out of a powder or a resin machine because it will always need washed, blown off, whatever else it was. And powder is toxic and resin's getting better. To be fair to resin machines, they are more scalable than FDM. But the issue with that is that resin is such a specialized material right now that it does not access the same feedstocks that FDM does. We get access to the entire injection molding supply chain that is fully commoditized. I can get plastic for 50 cents a pound. I cannot get resin for 50 cents a pound and will not for a long time. And it's so tightly controlled within a few companies, I don't have redundancy either. So I cannot force that pricing or nudge that pricing in any sort of way. So
yeah, everything
FDM,
you're saying makes perfect sense. And I want to, you said, an average human. I imagine a big part of that is when you say average human, you mean you can scale up fast because you don't have to train people to use the powder machines. Yeah, that makes a whole lot of sense. Although I will say I'm really excited about, I'm probably not going to get one, but that Micronics machine, it's like a desktop.
Yeah. It's pretty sick.
Cool. It's going to be cool. Someone asked a really important question as well. I like to try and give credit. Aton asked, what kind of precautions do you take around air filtering and VOCs, even when printing PLA at your scale?
We have active carbon filters inside of the building. And quite frankly, our main factory used to be an old train factory. So old train factory. So it just kind of leaks like a sieve anyway. So we just have air coming in through the walls anyhow. But no, we have active filtering inside of the building. Yeah.
Yeah. And then does OSHA come through and check this kind of stuff? I mean, what's that like?
Oh, there's all that kind of stuff that you got to deal with. But compared to an injection molding facility, our rate of emissions is wildly smaller, even with all those machines.
I imagine you don't print a lot of ABS, probably.
Oh, we try to avoid it. I don't know why ABS exists anymore.
I love ABS. I love it, but I'll tell you why. I'll justify.
Why? Okay, go for it. Why don't you use
you
ASA?
first? You first.
It's terrible. It warps. It emits all the stuff. It's awful. An ASA is exactly the same but better.
Okay, I'll give you that. I used to have a lot of problems with bed adhesion with ASA, and then Magigoo hit me
Okay.
up, and they're like, our PC works even better. Our PC, they have a PC one. They're like, it works even better on ASA, and now ASA sticks for me better than ABS. So now I agree with you. Like ASA is better in
Okay.
every way, but
Yeah.
if it's between like printing PETG or ABS ASA, like I'm taking ABS ASA all day long.
I can understand that. Yeah.
Yeah.
PETG absorbs a lot of water.
It's impossible to print here. I can leave it out for 3-4 hours. It's unusable because we have
Yeah.
75% humidity year round. It's like it's not.
We're below
It's not
20
printable.
all year round.
Yeah, it's not printable here. And that same friend is from Moscow, and he's like, all the PETG you get here is so unusable, like it's so garbage. I'm like, that's not the product, that's the environment. It's like, oh yeah,
Yes.
right.
Yep.
So you guys print quite a bit, I guess, of PLA and PETG.
We do a decent amount of PETG, but then ASA and engineering grade materials. We try to do a ton of TPU. We're trying to get everybody into hydrometer TPU because TPU is the god material, but it absorbs a lot of water too. So we get away with it up here, but anywhere else on the planet, it's terrible.
Yeah, and I recently had this epiphany of like, all my kids' toys should just be TPU, even if it's high shore hardness, because they won't break it. You know how quick they break everything I print for them? Everything.
Yeah. Oh yeah. No, TPU is a magic material for FDM.
It is. If you're patient, you got to be patient. Although I will say Polymaker just sent me a ton of, they have like high speed sonic TPU they just came out with. I haven't tried printing, so I can't comment. But if anyone's going to crack the figuring out how to make a troublesome material better, it's going to be Polymaker.
Polymaker's a fantastic company. I love what those guys do.
They have just some fantastic, I mean, all the founders are like PhDs in chemistry. Yeah. So that's a big part of it. So we got more good questions coming in. I love that this is turning into a Q&A because I got all my questions answered. How do you deal with vibration and sound with a rack full of printers running that fast at one time? That's a great question.
Sound's not a problem. You build good machines. Vibration, again, also kind of you build good machines. The vibration dampening and that kind of stuff is native inside of the control system. So it's not that bad. And then the racks themselves, when you have vibration, there's the dampening that you can put on the shelves, but also when all the machines are just active, you don't have resonance because they're all in dissonance to each other. So they sort of cancel each other's vibration out to a certain degree, to where it's not as big of a deal as many people attribute to it.
That's interesting.
Yeah.
And I think it probably helps that they're not bed slingers, and they're also, like sturdy and that helps. You're not moving the kind of masses. Like my shelves didn't move that much until I started running. I don't want to name names, but I got a few bed slingers that I really like, and I run them a lot now. I used to, any bed slinger I got, I would throw on the shelf, except for like the Sovels. I like those, but I got a few bed slingers that I really, really like that I run all the time. And now I'm like, oh shit, all my shelves are, vibrating. Itai wants to know, do you guys also offer modeling services for customers who have a business idea? Because you guys release a lot of awesome modeling tips.
That we don't. We don't really help with design if you're at Napkin Sketch. That is why we release all the modeling tips, so that there is a resource for people. But we just don't have the staffing to help with every one of the projects. And quite frankly, it's just kind of expensive to have somebody model it for you. Yeah. Fiverr is really great for that kind of stuff. Yeah.
My wife actually works at Fiverr, so I'm going to give people my link to Fiverr Business, because people don't realize they actually call it Fiverr Pro now. Fiverr has, there's like Fiverr where you can spend $5 and have someone record a funny voicemail, but they actually have like services all the way up to $50,000. And the Fiverr Pro, I'm basically pitching for my wife now because this is her department, but Fiverr Pro is for people who specifically want to use business related services for their actual business. And it's only vetted sellers. So you get only super high quality. It's a little expensive, but that's what we use for our thumbnails, for any like audio work we've had done, music. Yeah. Highly recommended. What's next for you guys besides tangled filament? What are the next big steps that we can look forward to?
Our big goal is to make both print farms as easy to access as possible and invisible. We think they're an infrastructure more than they are really anything else. So the stuff that we really focus on right now is kind of the software side. So like our API, which runs the Etsy integration, which runs the POD, because that allows someone who wants to access a large print farm do it just by uploading a file and running with it. So right now it's really cumbersome to use print farms because you send over a file and they review it and we quote it and so on and so forth. That's fine if you're making more than 1,000 parts, but if you're onesie twosie and messing around with it or wanting to iterate really quickly, it's really cumbersome that way. So the software solutions so that anybody can upload a part and get it made and shipped to wherever they want it to be, that breaks open 3D printing to really be accessible because it's no longer buy and understand or use a 3D printer. It is learn how to model a thing and upload it. So it's like learning to program and putting it on a server on AWS or something. It goes away from the early days where you bought a big old server rack and stuff and then you could run Google, and it turns it into like you can now become Zuckerberg where you just write some code on a weekend and now you got Facebook and that's all you had to do. You no longer have to build a great big print farm. You can just upload the file or connect it to a Shopify store, and then you print and ship the stuff for people. So now physical products can evolve and be created way more basically for free when historically they've never been that way. And even with 3D printing, it's still an investment to build a 3D printing Etsy store when it should just, when other people are doing stuff way easier and way faster and bigger. So we think we can make our scale available to more people, and that's mainly
really
through the software
cool.
source.
And then you guys are looking to add colors as well, because I'm just remembering my parts are 2 different colors, and then a little tiny bit of assembly. They click together. So now I gotta think how I'm
assemble.
Yeah,
we don't. Yeah.
Well, the user can assemble it. It's literally going.
You know? Okay, cool. Then that's good. Yeah, we're trying to avoid assembly here for a little bit just because complexity, but it's 2 different colored parts, right? 2 separate parts. They're different colors.
I can show you.
All right, that's
I don't want to turn this into a consulting session, but
that's all right.
Ask, by the way, if you have consulting services, so maybe I'll ask that as well. Someone wants to know if you offer consulting if they want to set up a farm of their own.
No, we don't help with setting up farms of our own. I don't recommend setting up your own farm, and I know that's self-serving, but but like it's a nightmare setting up your own print farm because as soon as you pass 10 machines, it turns into a job, and it's just it's a bigger commitment than many people realize.
I'm looking at this part that I printed on a CR10 probably 3 years ago, and I'm just like, I would not accept this part today. I mean, look at the VFAs on that. It's amazing how far we've come, and this probably probably took like 18 hours to print. And look at those VFAs and all the ghosting. I would not accept this today as a part, even if it took only 6 hours, which is what it would probably take.
That's fair. Comment on that though. The 3D printing community needs to get off its own back about like print quality because a normal consumer would be jazzed about that.
True.
We're all like, oh no, it can be so much better, but it's like, no, you're too close to it. Normal people think that's amazing still. So there's
probably. I mean, it actually has so much artifacting that it almost looks intentional. I don't know if you can see in the camera, but like every single crease is. It's pretty bad. But you're right. It's to the point where it's so bad it's good.
Yeah.
But yeah, this is the assembly. Doop.
Oh, okay.
Yeah. User can do that.
Oh, for
apparently.
Sure.
Anyway, when you add gold, because everyone orders it in black and gold, let me know.
Okay. Oh yeah, there's a tip for you for all you selling stuff. I think Etsy sellers and everybody else has to have too many options to where you're giving the customers choice fatigue. So calm yourselves down. 5 options tops, if even that. On stuff.
And then my big eye opener was the guy from Matter Hackers said, the CEO of Matter Hackers said, and I agree with him. He's like, if it's aesthetic parts, you do a lot of functional parts, so I don't think I'm going to offend you with this, but he's like, if it's aesthetic parts and it's just one color, it's more plastic crap. But as soon as it's, it has different pieces and colors, again, we're talking for toys and stuff like that, right? Like as soon as it's multicolor, now it's something special. And so my realization, I didn't come up with the idea. Someone actually poached my model off Thingiverse and then put gold accents on it. I was like, well, if you're going to steal my model, then I'm going to steal your idea. And I stole it back. And then I realized, like, you put that gold piece in and all of a sudden it's special. It's like artwork. Yeah. Right. Whereas before it was just a black bull, like the million black bulls on AliExpress.
That's fair. No, yeah, I could understand that. I think there's a lot more room to run with single colors because I do believe the constraints can make you make something really special. But yes, the multicolors definitely elevate stuff a bunch.
Right. If you're selling art and toys and things like that. If you're selling functional parts, again, to bring up Trav at Shop Nation, he offers 3 colors to match, your DeWalt, your Makita, your whatever. It's a tool. Don't need multicolor on there. But for all the like artistic stuff that people are selling on Etsy, like even the simple change, print off 50 of them, change the color at a certain layer height and have the writing in a different, black on white makes a big difference to kind of it not looking like, as he put it, more plastic crap. But again, I think you're not in the tchotchke business. You're in the printing final products that are functional business, I would assume.
We focus a lot on functional, but there's more of the consumer goods than you would think. I would say we're actually probably about 50-50 split between consumer goods and industrial goods. So there's the wheels, brackets, gears, and then vases, pots, things.
Really? That surprises me, actually.
Yeah.
Are they? No, I imagine it's like a special design of a vase. Like someone who designed the vase is.
Yes.
Yeah. Okay.
Yes, it's the geometry control still because we do not do multicolor in any format. It's like you got to make the whole part in black or whatever it happens to be. So there's that constraint on it, but there's so much you can do with that if you go then into like the modeling and you're like, oh, I'll change the texture here and I'll give that a vein so that you get that same kind of contrast and intentionality to create the quality.
Sure. Yeah. Totally. Gabe. Kuba asked a great question for Gabe. What do you think about automated systems out there that are out of the box, like the Mosaic Array or the Prusa Pro AFS?
I think there's going to be a lot of value to them because setting up a print farm right now, a print farm where you buy a bunch of printers and put them on a shelf is a jerry-rigged system. That is really bad if you're putting it in a factory. So the Array and the AFS are both really good to put inside of a factory to have a reliable, continuous prototyping system.
Yeah,
I do not think they solve the problem of scale. I think they scale up prototyping which is fine and needs to be done, but I don't think they're going to scale up. Oh, we're suddenly going to make 10,000 parts with this system. I don't think they changed that. So I think there's still room to run on that, but they certainly have a place.
Do you think that you guys have solved scale, or you're saying that as an even we haven't figured it out?
We haven't figured it out perfectly. We're really close. I would say of the ones out there working on it, we've certainly come the farthest because we generally competing against injection molding, we match injection molding up to 100,000 parts. Wow. And 85% of products never pass 100,000 parts. So we can produce 85% of plastic products out there. Oh, yeah.
That's
even
wild.
The things you see in Walmart or international retailers, they generally don't sell 100,000 units. They're like small businesses producing these things. So Toyota, I use the reference of Toyota. Toyota considers 25,000 to be a bunch of pieces for any given car part that they're making. Yeah. So that's their batch size. So we figured, the biggest manufacturer on the planet goes to 25. If we hit 100, we're probably doing okay.
That blows my mind, 25,000.
I know, it's crazy, right?
It's so low. It's small. They're selling 10 million cars a year, but I guess
they have so many variations of it.
Right. And I immediately go to the window switch, but then I'm like, okay, but the left window switch is different than the right window switch on a Camry and on a Corolla, and the passenger, the rear window left is different than the rear window right. So that starts to make more sense.
This is true. To be fair, that is like the average number. So I'm sure they
Sure.
have some that they store up to millions of.
Sure.
But yeah, they do work in pretty small batch sizes because they never know if they're going to make a different car or COVID's going to hit or something else along those lines.
Right. Well, and I'm sure they've done it in-house to the point where they're like, we're just going to keep the mold in a warehouse somewhere in Japan. And if we want to do 100,000 later, we can do 100,000.
Right.
But that's very interesting about 85% of parts being under 100,000. You mentioned earlier that the average margin on injection molding is 3%. And I wanted to ask, does that include to the mold manufacturer, or that's for operating the injection molding?
That is the net profit of the average injection molding firm at the end of the year.
Okay.
So
Gotcha.
all in, once they've paid all the bills, they have a net of 3 under there. But to be a good, reasonable business, you should have a net profit of like 10%. If you're a great business, you have like 15 or 20 net profit after you paid everybody, paid all the taxes, all the rest of it. This is not EBITDA BS. It's actual profit. But so injection molding is operating on razor thin stuff. Plus, when you get to scale, okay, you get a client, they ask for 100,000 parts. You work with them for a year or two. The only direction to go is cheaper because that's the only benefit that you can get to them. So they come back to you and it's like, okay, we're going to make these parts again. World's changed. You guys should probably be giving us a deal because we're a good client now. So you get squeezed over time when you're in large scale production. So there's nothing you can readjust to move around to be like, oh, well, we can make the part better or we can make it faster, that kind of stuff. You can't squeeze that anymore. The only place to go is squeeze your margins further to keep the client and hopefully make up for it with other projects. It's a terrible, terrible situation to be in. The only reason, and this is, by the way, is the direction all of 3D printing is going. We're going to slowly commoditize ourselves down to this if we're trying to go for production printing. This is why we started out with production printing because there was room to grow there. But right now we're focusing on the print on demand software kind of stuff because we believe that the maximum volumes will continue to decrease to where people will not order 100,000 and store them in a warehouse. They'll order 10,000 every month or maybe 100 every day. And that way, that allows us to maintain margins long term while still giving value to the client because they can change their design at any time. As well as let us absorb, since print farms are kind of a teleportation technology, we can eliminate warehousing, shipping, and the manufacturing process. So we have 3 industries with margins that we're able to bring into the business so we can actually be sustainable and grow for a good 20, 50 years. Rather than for the next 10 years, driving the cost as low as possible and then just driving our margins as low as possible and turning into molding.
It makes a lot of sense. Like I said, you guys have done a lot of first principle thinking, and I really admire that.
Well, we've been doing it for a long time now.
Yeah.
Working on
well, I want to be respectful of your time. Obviously, people can check you out at Slant 3D on YouTube. We're going to have all the links in the description. Folks in the comments, let me know. You also gave a TED Talk. Tell me about that.
It was fun. Yeah. Back when the whole company got started, we kind of laid out the premise of the whole thing and why print farms were a great way of making stuff and why printing could do it. But yeah, the TED Talk was a great process. They grab you early and then they force you to practice it for a while and that kind of stuff. And then you go up there and you talk to people for 20 minutes and can't go over.
18. It's got to be 18, right? Something like that.
It's 18. That's right. It is 18.
Yeah.
But no, the TED Talk is fun.
Very cool. Yeah, I did one. I don't even remember how long ago at this point. I think it was maybe in 2017. So a long time ago.
Oh, that was about the time of mine. I think I did mine 18 or 19 or something like that.
Cool. Very cool. Very, very cool.
Yeah.
Well, Gabe, we're going to put links to everything below. Anything that you want to encourage people to check out? Some time free time to plug?
Oh, well, if I'm allowed to plug, I'd say the Etsy integration. That's the thing. That will be the most useful to folks because you get access to a giant print farm to print and ship all of your orders. And then you can focus on making cool products and taking care of your customers rather than having to run a print farm, which can
amazing. I am 100% going to check that out and see if I can sell some of these with just one color. That would be awesome. All right, my friend. Yeah. Well, thanks for coming on and keep in touch. And we'd love to have you on again in the future.
Thanks for having me on. This was fun.
All right. Take care. Thanks everyone for tuning in.
Thanks for tuning in to the Infill Podcast. For show notes or links to anything mentioned in today's episode, visit thenextlayer.com. If you enjoyed the episode, please don't forget to leave us a review wherever you're listening, or click the like button to let us know. And consider subscribing to The Next Layer on YouTube so you can tune in live and participate in the next conversation. We'll see you on The Next Layer.